Hi guys, in this video we're going to have a look at how to calculate the length of an arc. So if you're unsure what an arc is, I have got a video on different parts of a circle, so definitely check that out because there's lots of different parts that you may or may not know of. But for this video, the arc is literally just the part of the circumference. So here I've got my arrows indicating that this here is an arc, it's the arc length. So it's just part of the circumference of a circle. And to work it out, it's very similar to the area of a sector. You need to have the angle when you have the two radiuses going to the end points of your arc. So the angle between them, we need to divide that by 360 because that is the fraction of the circle we want. The whole circle is 360 degrees, so I just want this angle of it. And all we do is we times that by pi d, which hopefully you remember is the formula for working out the whole circumference. So essentially all this formula is you work out the whole circumference and you times it by the fraction that you want of it, and that's going to tell you the arc length. Okay, so that's basically how the formula works. So it's quite nice and simple. If you remember the circumference of a circle, it's pretty simple. You just times it by the fraction that you want, which is what we're now going to do. So I want to know the arc length of this arc here. So I'm just going to substitute all those values into my formula. So I have 50, which is the angle, divided by 360, and I'm going to times that by pi, and I'm going to times that by the diameter. Now be careful, because this here, if you were to complete the whole circle, that's the radius, but you need the diameter. So I'm going to put a little note here. Diameter is 2 times the radius. In this case, the radius is 6, so the diameter for this question is 12. So I'm actually going to do pi times 12. So just be careful, you don't use the radius and you do actually use the diameter. Okay, so we've got 50 divided by 360. If you haven't got the fraction button, you can just do 50 divided by 360 and press equals, but the fraction button is on most calculators these days, and it does make it a lot easier. Times by pi, times by 12. So in terms of pi, that would be 5 over 3 pi, if it wanted it to be left in terms of pi. But if it didn't, press the SD, and it gives you it as a decimal. So 5.23598, etc., etc. And again, if it wants you to round it to a certain amount of significant figures or decimal places, obviously do what the question says. I'm just going to round to 1 decimal place. So the 2 is the first decimal place, 3 tells me to round down. So the arc length in this case is 5.2 centimetres, and it is a length, so it just stays as centimetres and nothing like centimetres squared or anything like that, because it's not an area. Okay, so that was the first one. Let's have a go at the next one. So again, before I do anything, I'm going to remember I need the diameter. So that's 2 times the radius. Oh, sorry, I thought that was 14, which is actually 11. So 2 times 11, which is 22 centimetres. And then I can use that within my formula here. So I have 130 divided by 360, because that's my angle, times by pi, times by the diameter, which we now know is 22, and we can work it out. So again, I'll use the fraction button, times by pi, times by 22, and we get the answer of 24.9582, etc., etc. So again, to 1 decimal place, 9 is the first decimal place, 5 tells me to round it up, so that become a 10, can't have that as a 10, so that goes to a 0, carry 1 over, so 25.0, and again it's a length, so it's centimetres. And the last one, just using this as an example, so this is a longer arc here, or this would be classed as the major arc as opposed to the minor arc. So a major arc is the bigger one, the smaller one is called a minor. So this is just going to be a major arc, but it's exactly the same formula. So the angle, which in this case is 230, divided by 360, and I'm going to times that by pi. I haven't looked at the diameter yet, so make sure you do remember that. 2 times 4 in this case, so the diameter is 8 times by 8. So always remember that, because that will trip people up. It's tripped me up a few times in the past, so learn from other people's mistakes is always a good thing. So 230 divided by 360 times by pi times by 8. And we have 16.0570, etc., when I press the SD button. And again, to one decimal place. 0 is the first decimal place. 5 tells me to round up, so 16.1 centimeters. So that's the basics of it. Let's have a look at how we can find the radius and find an angle if they're missing when we're told the arc length. So a bit trickier, a bit more fun as well. Here we go then. So here's 4 examples. It does get a bit tasty down here as well. Okay, so here we have an arc length. We're told it's 4 pi, so I know that the arc length is 4 pi, but I'm after the radius. Well, the first thing I'm going to do is I'm going to work out the diameter. So the diameter is 2 times the radius, so 2 times x in this case, which is just 2x. So once I've done that, I'm going to substitute that straight into my formula. So I'm going to have my 80, which is the angle, divided by 360, times by pi, times by the diameter, times by the diameter, which I know is now 2x, and that gets me the arc length. I don't know, again, keep drawing arrows, because that's what's coming in a minute. It gives me the arc length of 4 pi. So once you've substituted in your values, you can now use the flowchart. So the flowchart, we start off with x. What do I do to x? Well, I need to times it by 2. Then I times it by pi. And then I times it, then I times it by 80 over 360. And once I do all that, I get the answer of 4 pi. So then I can go backwards, 4 pi. And when you go backwards, you do the opposite. So that'll be divided by 80 over 360. And it will be divided by pi. It will be divided by 2. And it will get back to x. So let's put that into the calculator. I'll put it here so I can see. So I need to start off with 4 pi. So I'm just going to put 4 pi in and press equals. Yep. And do this step by step, pressing equals after each step, just so the calculator doesn't use BidMouse or get confuzzled or anything like that. So divide by 80 over 360, yes. I need to divide by pi, yes. And then I need to divide by 2. So I get the answer of x to be 9. Now once you've done all this, just check it and make sure it does work. So if I had 9, 2 times 9 would be 18, so the diameter would be 18. So I would do 80 over 360 times by pi times by my 18, which would be the diameter, and I get 4 pi. So yes, it works. So it's one of these lovely questions where you can go back and check you're right, so you can leave the exam hall knowing that you've definitely got that question right. So ever so slightly different. This time, instead of working out the radius, I want to know what the angle is. But we still do the same thing. We still work out what the diameter is. So that's 2 times the radius, so 2 times 27, which gives us 54 centimeters for the diameter. And I'm going to substitute everything into the formula. So I don't know what the angle is, so I'm going to keep that as theta. I'm going to divide it by 360. I'm going to times it by pi, and then I'm going to times it by the diameter, which I know is 54. And that's going to give me the arc length of 24 pi. And it's the same method. I'm still going to use the flowchart. So I start off with theta. What do I do to it? Well, I must divide it by 360. Then I times it by pi. Then I times it by 54. And I get the answer of 24 pi. So go backwards, 24 pi. Always do the opposite, so I'm going to divide by 54. Instead of timesing, I'm going to divide by pi. Instead of dividing by 360, I'm going to times by 360. And I should get back to my answer of, let's have a look. So again, step by step, 24 pi divided by 54 divided by pi, pressing equals each time, times by 360, and I get the answer of 160 degrees. And just as before, check it, stick it back in, 160, over 360 times by pi times by the diameter, which we had as 54. Yes, it gets 24 pi. So again, we know we're 100% correct. Okay, what's more likely to come up in the exam is a question like this, where they give you, I suppose it's a sector, isn't it? And they want the perimeter. So obviously we know this length. We know this length as well, because if it's part of a circle, that's the radius, and that's also going to be the radius. But what we don't know is the arc length. So that's where the actual arc length question comes into it. We need to calculate that, and then add 7 to get the whole perimeter. So let's do that. Let's calculate the arc length first. So that's going to be 25, which is the angle, over 360, times by pi, times by the diameter. So remember, diameter is 2 times the radius, so 2 times 7 in this case, which gives me a diameter of 14. And I need to do that. There we go. So let's substitute that into the calculator. So 25 over 360 times by pi times by my diameter of 14, and we have 3.0543, etc., etc. So that's the arc length. I then need to, if I just write it down here, 3.0543.0, etc., etc. Again, keep it on your calculator, and this is just for the purpose of showing the examiner I know what I'm doing. So I've got the arc length. I then add 7, so add 7, and I get the perimeter to be 17.0543, etc., etc. I'll round that to 1 decimal place. So 0 is 1 decimal place. 5 tells me to round up. So I'll put it here because that's where the answer is there. 17.1 centimetres. Cool. Excellent. Right, so that's how you can work out the perimeter. Just make sure you do read the question. Don't just work out the arc length, stop there and forget to then do the simple bit at the end, which is just adding the 2 sevens. So make sure you do go back and read the question and just spot that potential mistake. And the very last one I've got for you guys is, when you're told the perimeter, how do you go back and find the radius? So this is quite a tricky one, if I'm being completely honest. So yeah, let's give it a go. So first thing I'm going to do is get the diameter, just as we've done before, and do 2 times the diameter, which is x. So the diameter in this case is 2x. Okay, I'm then going to substitute it into my formula. So the angle is 300. I'm going to divide that by 360. I'm going to times it by pi. And then I'm going to times it by the diameter, which is 2x. Now that's the arc length. But remember, the perimeter equals 152. So once I've worked out the arc length, okay, you can put that in brackets if you want to say that that's the arc length. I then need to add this length, which is x. And then add this length, because it's the radius. Add that, and then that's going to equal 152. Right. So you need to do a little bit of simplifying now. So if I ignore the x here, I'm just going to do 300 over 360 times by pi times by 2. Because that's going to give me a number that goes in front of x. So 300 over 360 times by pi times the 2. So literally all these are times into, I'm going to times all those, and that's going to be what's in front of the x. So when I press equals, it's going to give me 5 over 3 pi. So it's 5 over 3 pi x. So this is just a number that's in front of x. X plus x is 2x, and that's still going to equal 152. So just like if I just come over here, got a bit of space here, if you say had 3x plus 2x, just simplifying, you add the numbers in front of them because you both have x's to give you 5x. So that's just the basic simplifying. Okay, don't need that though. But it's exactly the same thing here. This is just a number. 5 over 3 pi, if I then press the SD button on it, is 5.235. So it's not very nice, but that is still a number. And when I simplify this, I've got this number here plus 2 is this number here. So what I actually am left with is 7.2359, etc., etc., x, because I've just simplified this number, and that equals 152. And then all I'm going to do is just solve this equation. You can use the flowchart. I haven't got enough space to do this, but all we're going to do is divide it by this number. So I'm just going to use the balance method. If you were using the flowchart, you do x times this equals 152. So 152 divided by this gets you x. So I'm just going to write that down. Divided by 7.2359, etc., etc. Both sides. Notice I've still got it on my calculator. Don't get rid of it, because we want to get the most accurate answer we can. 2359. So I'm running out of space here. So don't get rid of it, because that's your whole number. Just do the perimeter, which is 152, divided by, and if you press the A and S button, it uses the previous answer, which was our long decimal. Press equals, and I have 21.006, etc., etc. So to one decimal place, it would just be 21.0. And that's what the value of x would be. Perimeter is in centimetres, so it would be 21.0 centimetres would be the value of x. So that is a bit tricky to get your head around. Hopefully that does make sense, that's a number, that's a number. So I'm just going to add them, and that's what goes in front of x. It's just that simplifying expressions. So 3x plus 2x is 5x. So this number plus this number gives me this number in front of x as well. And then it's just a rearranging. So a few different things to get your head around on that one. So it's a little bit tricky at the end here. Be careful of the perimeter, be careful of the diameter. Make sure you always work out the diameter, because obviously it's pi times diameter, that gives you the circumference, so make sure you are doing that. And if you've got anything missing, just substitute it into the formula and use the flowchart to solve it. Hopefully that helps, guys. Thanks for watching.